The amount of trash produced by the average American is normally distributed, with mean 2.5 tons of trash per year with standard deviation 0.4 tons. A. Find probability a random American produces between 2 and 4 tons. So we draw a normal distribution, and this time the variable is x, and we know what the mean is. It's 2.5. We want to find the probability that x is between 2, which is going to be to the left, and 4, which is going to be further to the right. So in order to do so, we have to transfer our problem from x into z. And so what we use is a formula from our sheet. And this one is probably one that you might just know, or will shortly, definitely after the midterm, which is in Chapter 6, the standard score. To get a standard score, a z-score, use x minus mu over sigma. So we're going to take z equal to x minus mean divided by sigma. So that's going to be 2 minus 2.5 divided by standard deviation, which is 0.4. And we're going to take 4 and go 4 minus 2.5 divided by 0.4. So what we're going to do now is say that we've transformed the problem from saying the probability that x is between 2 and 4 tons into a problem of z. And that's in between, and break out our calculator now. Parentheses 2 minus 2.5 divided by 0.5 gives us negative 1.25 less than or equal to z less than or equal to 4 minus 2.5 over 0.4. And that turns out to be 3.75. And so now that we translate this problem back into a problem of z, we remember that what we have to do is look up the bigger number first and then subtract off the smaller number. So let's look up 3.75 first on our z table. And 3.75 is positive, so we go down. But you'll notice the z values only go to 3.49. There's this little disclaimer at the bottom which says, for z values greater than 3.49, use 1. And the reason why is if you go out more than 3.5 standard deviations, you get almost the entire curve. So we're going to use 1. So our answer is 1 minus the probability that we look up when we look at negative 1.25. Remember, the left tail would be probability of 1. We want to subtract off the part we don't want, which is to the left of this value, which turned into negative 1.25. So let's carefully look up negative 1.25, find its probability, and that's what we'll subtract off. So negative 1.2, slide all the way over to the 0.05 column, and we get 0.1056, and we'll take that away from 1, and we'll get our answer, which is 0.8944. And finally, B. If 90% of Americans produce more trash than you, how much do you produce? So, in this case, they're really asking us for x. We don't know what x is. So we can find this using our formula sheet under Chapter 6, which is the raw score, or x, as they call it, is z sigma plus mu. So that's what we're going to use here. X equals z sigma plus mu. And what we have to do is draw our normal curve. Now, we're given what mu is, that's 2.5. We're given what standard deviation is, that's 0.4. We just don't know what this guy is, the z-score. They tell us 90% produce more trash than you, so in other words, 90% is going to be to the right of you. So 0.9000 is to the right of you. So first, let's work with z-values, and then if we find out what z-value this is, we can plug it into our formula and we'll have our answer. Now there is one tricky thing about this, and it's not real tricky, just to be careful of. Since we always have left tails on our z-table, what we're going to have to do is find the area in our left tail. If we look at 0.9000, it won't work. So we look at its complement, which is 0.1000, and that will give us just what we want. So go into our z-table and looking up 0.1. As close as we can get to 0.1, it looks like 0.09, 0.11. So let's slide over and see how close we can get. It looks like we can get to 0.1003, and then the next number is off too far. So our z-value, we're starting with probability again, is negative 1.2, and that second digit is 8. So we get a negative 1.28, and therefore our raw data score, or the amount of trash produced, is negative 1.28 multiplied by standard deviation of 0.4 plus the mean, which was 2.5. Multiplying this out carefully and then adding gives us 1.988, and this would be in tons.